So for something like this, so the first thing you always do is factor out the greatest common factor. So I'll just do that in red. So our greatest common factor here, so we always look at the number. So I'm looking for the biggest number I can divide out of 2 and 162. Well, the biggest number I can divide out of 2 is 2, exactly, yeah. And that goes into the other one. So that's easy. And then because there's no variable in the last term, I can't take a variable. So the greatest common factor is going to be 2. Right. So put that in front. And then I'm going to divide each of these by 2. So basically, I'm pulling the 2 out from the 2a squared.
Okay, that makes sense.
Because 2 divided by 2 is 1. So you could put the 1 there. It's not necessary. So too much erased.
Yeah.
And then you're also dividing 162 by 2, and that gives you 81. So you're just pulling a 2 out or dividing it out. You're putting it in front, and if you multiply it back through, you'll get to what you have before.
Mm-hmm. But it's not done, is it?
Correct. It's not done because now this is the difference of 2 squares that we need to then factor. And so that's where you want to learn the shortcut for the difference of 2 squares.
Okay.
So if you have something of the form, let's say x squared minus y squared, it's something squared minus something else squared. Actually, let me not even use variables. Something squared, oops, minus something squared. This factors to that first thing plus the second, and then the first thing minus the second. So I'm going to use highlights here. So we have first thing squared, and that goes in the front, and then second thing squared, and then that goes in the back. Oh, man, I keep accidentally hitting that picture, and it wants to move, really wants to move. So our a squared minus 81. So we know what the first thing squared is. That's a, because it's literally written that way. So this is going to factor, that's going to be the first part of each one, and then I can put in my plus and my minus. And then we just have to figure out, well, 81 is what squared? So 9 squared gives you 81. So 9 is going to be those other numbers. And then that's your final answer there.
Okay, well, that wasn't too bad. Let's see. Let's go on.
Yeah, it really isn't. It's just a matter of you need to know your times tables or know those perfect squares. If you know like the times tables up to 10, like what you learned in elementary school, you can do most of these pretty quickly.
So let's go ahead and, if you don't mind, I'll change the chronological order, and let's go down to 16 Z. It's the last. It's number 8.
Oh, that one. Okay.
And then 81.
Okay. So this one's a tricky one.
Oh, it is so different.
It's not that tricky. It just is. This is one of these things that they call quadratic in form. It's just got a little trick because it's not obvious that you have something squared in the first part. Like 81 is 9 squared. That part is okay, but it's like, well, what are we squaring in this first part here to get the 16z squared?
Oh, well, wouldn't it be 4 and then z to the second?
That's correct. So you're already ahead of it because you figured it out right away. And most people struggle with that.
Get 2 points for the moment.
So since that's 4z squared, since 4 squared is 16, and then z squared will get you z to the 4th. So then when you write this, you have 4z squared and 4z squared with your plus and minus. And that's why I put it in parentheses, so you can see that that's like the first parts. And then we have our 9 in the front and the back.
Yep. And that's the answer.
And that's the answer.
Okay.
Actually, oh, I just noticed, because actually we can, this is another difference of two squares. Or another, yeah, difference of two
Oh, we can
squares.
go one more.
We can go one more right there. So sometimes you have to be careful and you're like, wait a minute, there's more. So, oops, should be two. This first part, if there's a plus in there, it doesn't work. There's no rule. We can't factor that. But we can do it again with that, what I've highlighted, because the 4z squared, that's 2z squared. So I can put that in the front and the back. And then 9 is 3 squared.
That's right.
And then we should double check. Well, those we can't do anything further. So that is the final answer.
Very interesting. Okay, that makes sense.
Yeah, it's one of those things where it's like you have to double check. And this would be like, if it says factor completely, you want to look for things like this, because there's going to be more than one step.
Okay.
So this, yeah, go ahead.
If we had been looking at this, wait, why did we put, oh, I see, we put the initial one first, which is the 4z, the second, plus 9, and then we broke it down to 2z and minus and plus 3.
Yeah.
Now, if it doesn't matter what the exponent is if we want to break it down one more time, like we did this with the 9.
We would have to make sure that it's something that is squared.
Okay.
So if it was a 3, that wouldn't work, because
so it has to be squared.
Yeah. Okay. And generally that would have to be an even exponent. You see, if we'd z to the 4th, because that's something that you multiply by 2, basically. So if the exponent can be divided by 2, then it's likely that you can split it up.
Okay. Okay, great. Well, let's go back over and look at, I think it's number 7. 6 w to the second minus 6w.
Okay.
So the greatest common factor is going to be 1, 2. No, is that right? Am I saying it right? 1, 2, 3, and 6?
Yeah, those are all the factors, and then 6 would be the biggest one, so that would be the greatest common factor.
Okay, so then we put the 6 outside, and inside is going to be w to the squared minus, there's 6, the other one is the w. Okay, so we got to do 6w on the outside, right? Okay, 6w on that side, and that leaves a single w inside the parentheses minus w. No, 0.
1, because we're dividing, so 1 is left over.
And
yeah, and that would be it, actually. We wouldn't even need the difference of 2 squares with that. So
so it's w minus or plus 1?
It would be minus.
Okay.
Yeah. I want to show you what happens if you didn't notice that you were pulling that w out. Like if you had just done the 6.
Okay.
You see how we have this w squared minus w, and let's say you're at this point and you're like, oh, shoot, I need to pull out a w.
Yeah.
If you do that, you just kind of stick it on in front, and then you can still factor from there and pull it out.
Okay, gotcha. Thank you. Thank you.
Yeah, if there was a number, like if you realized there was a bigger number, you would put the number, and you'd have to multiply those 2 numbers together.
Okay.
But it just kind of It keeps wanting to move over. It just sticks out in front. So if you notice that you didn't actually take out the greatest common factor immediately, you can still do so at a later point.
Oh, wonderful. Okay, thank you.
Mm-hmm.
Thank you. Okay, so I think we did the three that we initially pointed out.
Right. So 9.
3t.
This is.
Mm-hmm. Go ahead. I'm sorry.
I was going to say this. So this is one where I would do guess and check, but you can also do the AC method.
Let's see. 3, 13, and 4.
Mm-hmm.
Well, let's do both.
Okay, we'll do both. So I would do it by guessing and checking because the combination numbers to get to 3, there's only 1 and 3. There's only one choice there. So I know I have to have a 3t and a t. So that limits my guessing and checking already because I know what the fronts have to be. Okay. Because all the signs are positive, I know all of these have to be positive. Yeah. So now all I need to do is figure out the combination to multiply to 4, and then I have to get these to add to 13.
Ooh. So multiply to 4 and get to 13?
Well, we have to do with combination with the 3 here.
Yeah. Yeah.
So
okay.
4, I know I can do 1 times 4 or 2 times 2. I look at these numbers, I've got a 3 and a 1, and I immediately think, well, if I do 4 times 3 is 12, and then I have 1 more, and that will get me 13. So just by looking at the numbers I have.
Oh, gotcha. Yes, yes.
And then you test it. You got the 1t, and then 12t, that gets you your 13t. So that wasn't bad at all. Like, that was.
No, huh.
You don't have a lot of possibilities, and it's like, well, I know my times tables, and I know that 4 times 3 is 12, but that gets me really close, and in fact, it gets you right there.
Right. So, okay. Well, that wasn't all that bad.
If we did this with the AC method.
Yes.
So with the AC method, I would have to first do 3 times 4. And then I would have to get the combination of numbers that multiply to 12 and then add a 13 in the middle, which would be 1 and 12. So those multiply to 12, they add to 13, and so that's how I would split it up. So then what I would have to do is 3t squared plus t plus 12t plus 4, and then start going through the grouping.
Uh-huh.
And it actually ends up being a lot more steps.
Yeah, you're right.
Yeah, so that's where it's like, well, if the numbers are small enough, it's usually faster just to do guessing and checking. But I'll go through here.
So at this point, then we would go to the greatest common factor again.
Yep.
Greatest common, which is going to be 4. No, it's going to be 3.
But we can't pull 3 out of the t.
Right. So just t.
Just t. Yep.
Okay. Greatest common factor is t. Okay. So then we go t on the outside.
Mm-hmm.
In the parentheses, there's going to be 3 and then t plus, I always forget what to do. Oh, 1.
Yes. Yeah. If you put that 1 in front of the t above it, then you can see, oh, I removed that t, that's going to be a 1. But if also you think about it as dividing, we have to have something there. It's not 0 because we still need to be able to multiply it back out. So we put that 1.
Okay, 1. And then it's going to be 12 plus 4 because you moved the t, right?
But we moved the t only out of the first 2.
Oh, that's right. Okay.
Yeah. Then we have to treat the second 2 separately.
Oh, see there? I forgot that step. Okay, so then that will be 3. That will be 4.
Mm-hmm.
So the greatest common factor is 4. So then 4 into 12 is 3 plus 1.
3t plus 1.
3. Mm-hmm. Oh, that's right, because That's right.
You pulled it out from the other.
It was gone.
Yeah, all these are the little details that like things can disappear, and then you're like, oh no.
And then it is. Then the way we write it is. This is the part. Okay. So this was for here. So I know I'll write down the last print first because I know it's going to be T and 4, correct?
Mm-hmm. Yep.
And the first one is going to be Oh, yes. Oh, right there. It's 3T plus 1.
That's correct. Yeah, so you get the same answer, but it certainly takes more steps.
Yes, it does.
Yeah, so this is one of the things that like can slow you down on a quiz is if you take the long way every time, you know. So
yes,
you want to look for the shortcuts and say, okay, these numbers are small enough, it's probably quicker, and to do it mentally with a trial and error kind of thing than to try to go through the AC method, which gets you the same answer, it just has more steps.
Right. Okay, T plus 4. Okay. All right, so that's doing pretty good. Now, let's see. I know we learned more yesterday than just those 4 equations. So can you pick one that, or another thought that we could go over, something else that you went over yesterday?
Yeah, let's see. I want to find one that I wouldn't. Okay. Well, all of those are pretty easy to do, guessing and checking, because the numbers are pretty small.
Right. It's been bigger.
Yeah, let me see if there's a different one that I didn't copy over that, because some of these, like if there's 4 terms, you immediately want to do the grouping there. Actually, let's do 11, because that looks like a good one.
3AC plus AD minus 3BC minus BD. Ooh.
Yeah, so if you've got 4 terms like this, you immediately want to get it to zoom. I think it really doesn't like that I have this image. It like keeps freaking out. Oh wow.
So we're looking for the greatest common factor.
Yes, and if there is one with 4 terms. Now it's usually harder to find one with 4 terms.
You're right, and there's not.
And there's not, right. So that's where we want to go into grouping. So I'm going to rewrite this.
To grouping. Okay, that's right. Sometimes we want to do that. Okay. Do we go? Yeah.
And because my third term has that minus, when I group it, I want to put a plus in between my groups, and then that minus goes in the parentheses.
Great. Plus AD plus BC. Oh, there you did it.
Yeah, I went to the keys. my fingers usually, work on the tablet, and I could just use my fingers, but it did not want to.
Oh, okay. So now we look for the greatest, or do we go for the formula?
We want the greatest common factor, so that you don't want to do a formula unless you have something squared, and we don't have anything squared here. So these are.
I got to write that down. Only formula when squared. Okay, I gotta.
Yeah. So if there's nothing squared, then we have to do look for the greatest common factor here.
Okay. So the greatest common factor in the first set of parentheses are A. So we're going to put A on the outside, and then we're going to go 3C plus D.
Yep.
Okay, and the second parentheses, the greatest common factor is D. No, is that B? That's B.
B. I mean, yeah, so the letters, they get confused. And because the first thing in the parentheses is negative, we're going to also take out a negative. because we like to have the first thing be positive inside the parentheses.
Oh, gosh, okay, all right.
Oops,
so
I wrote D and it was supposed to be B.
So
we're all a little dyslexic here.
So it is a negative B.
Right. Oh, because we love to have parentheses have positives in there. So whenever you factor, if the first thing's negative, just factor out a negative. It makes things easier, and it will make sure these match it, because the first group that we have doesn't have a negative in the parentheses.
Yes, you're right. Okay, so as we move through the parentheses, it's going to be 3C minus D.
We have a minus. We factored out a minus.
Oh, that's right. So it's a plus.
So it becomes, yes, so that becomes a plus.
Okay, I gotta highlight these guys. Okay. So now they are the same. And so it's in the first parentheses is 3C plus D. Plus the second parentheses are A minus B.
Yes. And make sure those are written as multiplication. We don't have a plus in between those.
Oh, wait. Oh, see there?
Yeah, a lot of people are prone to do that, but when you factor, it's a series of multiplications. So your final answer will just be things inside parentheses multiplied together.
No sign. Okay. All right, great. Okay. That went well.
Yeah, let's see. Okay. It's not on my list here, but I think that I'm looking over at the book. So it's not on one of the ones that I copied here.
Right.
But I think this is a good one for showing when I would not use the guess and check or the trial and error. So 9W squared plus 3W minus 15.
Okay.
So if I can't look at this and immediately think I know what combination of numbers I need, then I will, or if it doesn't look like it's going to be an easy kind of thing, then I will immediately do the AC method. And in this case, that's what I would do, because 9, I have 3 times 3 or 1 times 9. And then for 15, I have 3 times 5 or 1 times 15. Right. And those are not a lot of possibilities, but it's enough that I look at these and I'm like, oh goodness, the combinations, like trying to add things where you're multiplying by 9 or 5, or like the numbers just don't seem nice. You know? It's like if it was like an even number, for whatever reason, those seem easier to me. But once you start throwing like odd numbers in there, that just seems like my brain's like, oh, this is harder. I don't want to do
it. Thank you.
Now, actually, as I look at this closer, we can make this a little easier because we do have a greatest common factor that we pull out.
Yes, greatest common factor, which to me is 3.
Yes. So let's factor that out and see if that makes this one any easier.
So 3 is going to be, inside the parentheses, is going to be 3W squared. Oh, wait. What am I doing? Okay. Plus W minus 5.
Now that we've done that, this looks easier. This looks like something that I can try to figure out. Because it's like, oh, well, there's only one combination that gets to 3, one combination that gets to 5.
Right.
And 5. I don't think this is factorable. I think that's as far as it goes.
Serious?
Yeah, because I'm looking at this, and 5 minus 3 is 2. I don't think there's any way to get to a 1 here.
Oh, I see what you're saying.
And we can even verify, so we can attempt it. So if I go back to, so if I put like a 5 and 1 here, the 5 times 3 will be 15, and then we have a 1. Like, there's no way that's getting close to.
No.
And then if I flip it and put the 5 and the 1, that's 5 and 3. That gives you 2. That doesn't work.
Yeah.
So, yeah. So that one, it's like you look at it and you don't. It's sometimes you have to think about it and be like, well, wait a minute. And if that's the case, then the trinomial that we have in parentheses is considered prime, but we were able to factor because we have the 3 in front.
Gotcha. Yeah. Well, good. Well, that was quicker than we thought, huh?
Right. Now, what we should do is say, okay, what if we didn't factor out the greatest common factor? What if we started doing the AC method? When do you figure out that it can't be factored? You know?
Yeah.
So let's just do the top, and let's just say, okay, let's just factor. Let's start from the very beginning and attempt the AC method, and I'll just rewrite it next to it so we can just repeat the problem. Because this is sort of the error checking and trying to find errors and all that kind of stuff. This is good stuff.
Okay.
So let's say we didn't notice we can factor out a 3, and we started doing the AC method, which is 9 times the negative 15.
No, so
I have to do that on my calculator. There's no way I'm doing that in my head.
Why am I confused by that first step?
So the AC method is you take the first number and the last number and you multiply them together.
So that's right, A and C. Okay, see, that's what I need to do. I need to write down the formula.
That is helpful, yeah.
A multiplied C needs to be, let's see, and then they should add to be a 3, right?
Yes. Yeah, so I'm going to have to start writing down all my numbers that multiply. So 9 times 15, or negative 15, I got 135. So this is going to be a long list. So I usually just start with the most obvious, 1 times 135.
There you go.
And then I start counting up from 1. So I know 2 won't divide into it because it's not even. So then I'll try 3.
Yeah, 3 might. Okay, I'm sorry, I'm not doing it at the same time. I'm letting you do it.
That's fine. Yeah. So we got 3 and 45. Okay. So then I'll try 4, and I just take my calculator and then I start going through it.
Now, you would have skipped 4. So yeah, because you knew 4 wasn't going to work, so you went to 5. Okay.
Yep. Yeah. And I just tried 6. That doesn't work.
Okay.
Just tried 7. Just tried 8. And I have 9.
9 might. Yep.
Now, 9 times 15, that gives you your 135. I only need to check up to 9 times 10, 11, 12, 13, and 14, because once I hit 15, it's already on the list. So I don't have to try every single possible number.
Yeah, that makes sense.
I know it's not 10. Pretty sure it's not 11. 12 doesn't work. 13 doesn't work. 14 doesn't work. And so that's it.
That's it. Yeah.
So now we want to get a positive 3 in here. And we'd have to do that by having one of these positive, one of these negative, because they're multiplying to a negative. Because we want a positive 3. The larger the two numbers is going to be positive. So all of these need to be negative here. Now I look at my choices. If I try each of these rows, none of them are going to get me to 3.
Right.
And so that's what tells you is that this can't factor further because none of these work. The closest is the last one, but that gives you 6. So if you do the A times C and you don't get anything that can add up to that middle, that's telling you that it's not going to factor further. But you still have to check for that greatest common factor because we can factor that out. We just can't factor into 2 sets of parentheses. It doesn't work.
Okay. So so if I was to choose to do this on an exam, it would be best to show both ways, or would you accept both one or the other answer?
The best answer is what I have boxed here, where we have the greatest common factor out.
Okay.
And so I would just always do the greatest common factor first.
Okay.
And then what would happen is then you would try to do maybe the AC method or guess and check, either way. And then you would find that it doesn't go further and you can just box it. You don't have to show the work for the other stuff, because you can do it in your head if you're really good with your crazy times tables like this.
No.
So you don't have to show that kind of thing. Especially with a lot of this factoring, sometimes it's just really easy to do in your head. Usually what I say, if you're going to factor, is at least write down the numbers that you determined. You know, like these two numbers add to this or multiply to this, just in case you have a multiplication error. You know?
Yeah, that's true. That's true.